Hello everyone, and now we are going to talk about something a bit different. In the last episode, if you watched it, which, you know, you probably should, we learned the final part of the tripartite course on the basics of Java programming in relation to robotics. But now we're going to actually get into robotics. So buckle your seatbelts and put on your caps and let's go. This is how to control a robot. Now, in robotics, the controls department, also known as the programming department overall, is in charge of coding the robot in the generalized sense, but more specifically, you have to transform the inputs from a controller, like this one, into the movement of a robot. Forward, backward, up, not ups, strafing, diagonal, things like that, throwing stuff. You have to do all of that, and you're going to have to learn how to do that over time. But what we're going to do today is give you a bit of a brief introduction to how any of that even works. So, generally though, your code looking like this, basically, this is what it looks like, will act as an intermediary between the driver's inputs and the robotic outputs. In other words, more directly, your actions on the controller, your button presses, your triggers, your movement of these, they are all taken into they're taken through a phone and transferred to the Rev Robotics Control Hub on board a robot. And this will then be connected to the motors and the servos and make it so all of the direct actual actions of a robot, which is kind of what we do robotics for, they're done through this control hub. Now, more specifically on the control hub, there are many different sensors that can be inputted into the control hub in order to then take that through the code, process their inputs, and then make outputs based on it. However, the most important things to know is that this right here, the yellow part that says battery, that is where you put in the connection to the switch, which turns on the whole system, which is in turn connected to the robot, which is this first yellow port. And the second port is in order to chain together the power from this battery, which is on board the robot, looks kind of like this, in order to go to a different type of control hub, which is called an expansion hub, which has more ports for if you need more motors. But if we look at the area labeled 0, 1, 2, and 3 in stripes of orange and black that we see on this side beneath the battery, that is where the actual motors are plugged in, which are these square ports right here, these 4 of them. And for our team, they will in turn be the front left motor in 0, the front right motor in 1, the back left motor in 2, and the back right motor in 3. It goes like this, in that order, which is just the standard, and it makes it easier to program it. However, this can be changed, but it's generally easier to leave it in that order. And they are connected, and those are the ports connected to these motors you see here, which are the ones that make the robot actually move, strafe, or go up and down and such. Then we go down here to where it says servo, next to the plus 5-volt power, which ignore that, where it says servo and then has the numbers from 0 to 5. That is where your servo motors go in. Those are the motors that bend, or not bend. Those are the motors that go specific amounts. They go degree amounts, and they make parts move more in a more controlled fashion. they spin blades, or they control arms or hands, or they are in charge of the finer movements of a robot controller. And then if we move on to this other side, where you have various other types of alphanumeric labels, this is where you have all the input devices, such as cameras or sensors or infrared sensors, heat sensors, pressure sensors, things like that. All of that stuff can be connected through here, but they are in general less useful in robotics than the motors and the servos as outputs. The inputs are not as important, although they can be, so it depends on how you wish to code it. Now, moving on from the control hub, we're going to talk about how the wheels actually work for robotics. So we use wheels that are a bit different from your average everyday car movement wheels. We use special ones called mechanism wheels, which allow us to use the wheels only moving in these directions, forward or backward, in order to not only strafe in every direction, including diagonally, and at any degree amount around the circle, but also the ability to turn easier and such. Which means that you don't have to put the wheels on turning bearings to have normal car steering or anything. You can just steer using the direct motor powers, using only 4 motors. And so, when moving forward, these mechanism wheels, so moving forward, backward, or turning, they will work the same as normal wheels, or pivot turning rather. They'll work the same as normal wheels, being, if you think of them as, like on this diagram, if you think of them as arrows, they're the way they're pointing as arrows, so the direction the motors are turning them, then all the wheels pointing forward, all the wheels turning in that way, will make the robot move forward. And then if all the wheels are reversed and turning the other way, they'll make the robot move backward. And then for turning, you need one side to be moving the opposite way as the other side. So you'll have if you want to turn to the left, you'll have the left side moving backward and the right side moving forward. And then reverse that for if you want to turn right. But for strafing, which I'm realizing now is spelled wrong, but that's okay. I was probably high when I wrote it. For strafing, on the side in which you want to strafe, you need to set the front motor power on the direction you need to strafe. So if you look at this diagram for strafing, the front motor power needs to move backward and the back motor power needs to move forward. In other words, the motors need to point in on that side in which you want to strafe. And on the other side, they need to point the opposite direction. They need to point out. So on that side, which means that if you end up doing that, your full robot, so let's say your full robot is this turtle right here, these motors are pointing in, and these motors are pointing out, and if you do that, then the robot will go like that. And so that is what you want to do. And then directly reversing every one of these, so the ones pointing in are on the left side, and the ones pointing out are on the right side, will make it strafe left instead of right. And then, moving on, we're going to talk about what robotics code in Java actually looks like. So this is in a program called Android Studio, which we will have you download at some point on our robotics team, and everyone on robotics has to download this. And this will let you communicate with the phones and the control hub that actually run this code on the robot. So it's an intermediary, as we said before. But if we look specifically at it, this is forward code. It will quickly use an if statement to check if opmode.gamepad1.write trigger. So what that is saying is take a controller. Op mode means controller, means the controllers as a total. Gamepad 1 is the first controller, because for FTC Robotics, first tech challenge, we use two controllers. One driver is in control of the movement of the robot, and the other driver is in control of the servos and the claw and whatever sort of intake mechanism the robot has, in order to make it easier on both drivers and also mean that you have more buttons to deal with. But what this is saying right here, the opmode.gamepad1 is saying opmode the first controller dot right trigger. So this trigger right here is greater than 0.1, which means greater than like this amount of pushing it down. So basically, is it pushed? Because the op mode gamepad 1 dot right trigger is a double amount, it's a decimal amount between 0 and 1 for how hard it is being pushed down. So if it's greater than 1, it means that it won't just go off constantly. It'll only go off if it's actually being pushed down a decent amount. And then what is happening is it is creating a new motor powers object, saving it into MP, which is instantiated up higher up on this page. It is creating a new motor powers object that is storing the values of left front, left back, and right back, representing the powers of each of those corresponding motors. And it is setting all of these powers equal to the amount that this trigger is pressed down multiplied by a trigger multiplier of around 0.7 to make it so it doesn't go forward or backward that quickly. And that is doing, that's just and that is the right trigger. So on the right trigger, you have all the motors set to negative values, and in which it will move either forward or backward depending on which direction your motors are automatically set to. And on the backwards, this is an exact replica except on the left trigger, and the motors are set to the exact opposite values. So if this one goes forward, then it'll set every motor here to move backward. And then we look down here at these two lines that says opmode.telemetry.addLine. This right here is printing to console. That's all it is. This is basically the same as system.out.println is opmode.telemetry.addLine, which will then print out this string to the controller phone. So it'll print out to the person, whoever is controlling the robot at the moment, will see trigger right forward active or trigger left backward active right here. They'll see either one of these. And then the opmode.telemetry.addData, which will add a caption of trigger right and then put in a double or integer value of this. So this is the same as just doing the trigger right and then putting a plus sign and then putting this gamepad right trigger value, which is the amount the trigger is pushed down. I'll remind you, it's the same as that. It is just a slightly different way of doing it. So that is basically string concatenation here. And if you have any other questions about this sample code, then write it in the comments, but we're going to move on. So we will start by doing robotics coding practice. Now, as you most likely don't have Android Studio, and most IDEs don't really even run robotics code, because the only way to run it is if you're actively connected to a robot, which presumably nobody here has, but I don't know. I mean, I can root around my bedroom. I probably have I probably have one somewhere. I mean, it's been a long day, but for most normal people who lead normal lives, they don't have robots lying around. Now, what we're going to do is just go into the online IDE, as we've been doing before, and not run any of the code, because it will error. So we're just going to practice it, and then you can keep it for later use if you wish. But we're just going to practice it here and not actually use it. But you're going to start by following these steps, and we have sample right here of it. You're going to create a double variable with a value from 0.01 to 1. So we're going to, let's say we're going to completely remove all of these and just do this in second.java, because that's Easy to do. We've already been doing that. So we're going to create a double variable of a multiplier. Double multiplier equals, and then I'm just gonna put 0.7 because that's the one that we use a decent amount. And then up above we'll create a motor powers MP equals new motor powers, and this takes a single double value for this one, and so we'll set the base value of motor powers to 0.8, and then put a semicolon there. And now what we are going to do is, I guess actually the best way of doing this is just set it at 1 at base. But now what we're going to do is create an if statement. So we'll do a if, and then if you remember from before, it is op mode. Remember, camel case, op mode. If op mode dot this controller right here being gamepad 1, so first controller, which is movement controller, gamepad 1 dot x, which indicates if the X button is pressed, being this. This one is not a double value because it's just a binary. It's not pressed, it's pressed. It doesn't have an in-between and doesn't really have a calculable amount to which it is being pressed, so it is just, you just put that. It returns true if it is pressed, and it returns false if it is not. Now, what we do is we put in, just like what we had here, we do, but not add this motor powers because the MP already exists. We do MP equals new motor powers, and then in here we put what we put is MP dot left front. Let's see. I believe it is. Let me move over. MP dot left front. Yep. Okay. It's just dot left front, which gives the value of the current left front, which you know already is 1, but we're doing it so it is possible that these values would be different. You do MP dot left front multiplied by your multiplier. And then what you do right here is you copy this 4 times. So you copy this 4 times and go through and do MP.left front, and then change this one to MP.right front. Change the next one to MP.left back, and the last one to MP.right back. And that goes through every one of them and multiplies them by the multiplier, and then saves it into a new motor powers object. So what you are doing here is just basically, because this is 0.7, you are slowing all of the robot's movements while you are holding down X to 0.7 of their speed, which is good for making precise movements. But what we do now is we want to tell the user what they're doing. So we will do a op mode dot telemetry. Let me quickly make sure that this is correct. Yep. Op mode dot telemetry free dot add line, and then put in quotation marks because it's a string. We just do slow multiplier active, which will then tell the user that there is a slow multiplier active. So this code, when used combined with other controller or robotics code that you would have added above or below this, it will allow you to slow down the speed of your robot by holding down X. So if you were using this code, for instance, at the same time and this code is above it, to drive it forward or backward, then it would and then it would start out moving very quickly. It'll move like that, but if you hold it down, it'll move slower overall, which makes it so you could do more precise movements like that compared to like that. And that is generally just helpful to give your robotics teammates more control when they are driving the robot. So that is it, though, for now, for the robotics sample code. So good job for getting through all of this, and thank you for choosing RoboRavens. Now, comment in the comments section how I may assist you further, and goodbye.